everyone, I am here with my next video of Q. It is a linear data structure in which I want to tell you how we are having a Q in our daily life and how we are going to apply it with the help of programming and how we are going to arrange memory in a sequential order by using Q concept. Now, first of all, a short revision of data structure. I told you earlier, data structure is already specified in a proper organization of data elements, and we can say it is a proper organization of data elements in which we are supposed to arrange it in a memory. How we are going to arrange a particular data in a memory is data structure. And we can say in programming language it is referred as data type. Data structure is basically of so many types, but we are considering only two, linear and non-linear. But now we have to go with linear, and inside linear we have to go with Q. Now, you all know you are in daily life, you have to create some lines somehow in ticket counter, somehow some in different position you have to create lines. And if you are not in a proper line, then somebody refuse us and don't allow us to stand there. In, even in schools, students stand in a queue. That's why the concept, when we store data in a particular order, in a sequential order, in a manner of queue, then how we are going to arrange it. Queue is a linear data structure. It is in the form of FIFO principle based. FIFO means first in, first out. This is FIFO principle. In Q, insertion deletion occurs in different end, and if we say if we want to insert element, then we have to move with rear end. If we want to delete element, then we have to move with front end. And it is coming in your mind, what is front end, what is rear end. See, both the ends were open. Now in this we are having two ends, this one and this one, both the ends were open. You can insert element from here, you can delete element from here. For deletion, front end is used, and for insertion, rear end is used. You have to keep few things in your mind. And one more thing, when Q is empty, it is underflow condition, means front end and rear end both were 0. Why both were 0? Because counting till now not started. That's why both the ends were 0. If you want a more clearance for rear and front, we will go further and each and everything will be clear for you. Now, for overflow condition, overflow means a particular area doesn't have that much space to store more elements. That's why overflow conditions occur. When it occurs, when rear end is equals to size. These two conditions we have to keep in mind when we insert element, when we delete element. Now how we are going to see these things happens. First of all, see an empty area I had already created for you all so that you can identify how it works. Both the ends were open. See, these are two ends, 1 and 2. These are two ends. From here we are inserting element, from here we are deleting elements. Means a room having two doors, this one, One door is used to insert element and one door is used for to delete an element. In this way you can see for each an element, when we insert an element, front and rear both come on 0th position. But before that, both front as well as rear is present in -1 location. Why? Because presently no element is in first position. That's why both were in -1 location. When we insert first element, maybe it is 8. When we insert a first element, then front and rear both should come in 0th location. Now what is front and what is rear? Rear indicates last element, front indicate first element. Presently 8 is front as well as last, first as well as last element. Now if we insert another element in this location, maybe 9, then front will stay there only because we are already inserted first element and then we are proceeded with next element. Then rear will increase and front will remain there only. Means last element, the second element is the last element of array. If now I am going to increase, means rear have to come here and we can insert another element in this position. Now in this way rear increase one by one and we can insert different elements here. Means now front is in 0th location and rear is in 4th location. Means each and every time front and rear will specify us which the first element and last element position. Now see, Q is a linear data structure. Q works on the principle of first in, first out. Means first person and ticket counter get ticket first and last person get ticket and last. You all know that. It is not new for you all. FIFO principle. And in Q you have to keep in mind different ends were there for insertion as well as for deletion. Means in the line when we are moving, we are entering line from last till first, and when the counter person is sitting here, when we are taken a ticket, we will move from here. Means when we insert, then we come from here. When we delete, we will go from here. It is a ticket counter. Means position were different. From here we are inserting element and from here we are deleting element one by one. Means we require two ends, two different ends for insertion as well as for deletion. And when we insert an element, then some name should be there so that we can specify both the ends. When we insert element, then it is named as rear end. When we delete an element or remove an element, that is front end, because the first person is standing in front and the first person will be removed first. That's why it is front end. Now see how. It is a queue in front of you all. You are having front end, you are having rear end. And from rear end, we will insert element, and from front end, we will delete element one by one. And now, when we are doing all these things, we have to keep things in our mind that if queue is empty, then it is under flow condition. How? When front end and rear end contains 0, or we can say null, then it is underflow condition. And when we are considering another condition, that is overflow, then we have to keep in mind that rear equals to size, means rear is comes in this position, then it is overflow condition. I told you earlier also about a glass of water. When a glass of water is full till top, then what happened? And again we are filling water, then start flowing down. It means overflow condition. The same thing you have to keep in mind again in Q also. Now moving further, when we are doing our insert operation, what we have to keep in mind? That first thing I told you, insertion, deletion from different ends. The name of the ends were front end and rear end. The doors, the different doors we are having. And now, when we are having nothing in our queue, that time what we have to do? Front and rear both are in -1 location when we are dealing with array, because from 0 we are having first element, and when we are not having any of the element, then the positions were -1 for both of them. And when we insert element number 1, for example, I'm inserting 8 here. I want to insert 8 first of all, but how I am going to insert? See, front is already present in -1 and rear is already present in -1, but I want to keep 8 in first location. Then our front shows us it is element present in first location. Now 8 is our first element, we have to place it here. That's why we have to keep in mind that front should come here in 0th location. And R will increase by 1 and it provides us 0, means both were in same position in 0th location, means first person will be the first person as well as the last person of a queue. Now when only one person is standing in a queue, that person is first as well as last. When another element came, for example, I am taking 9, I want to insert 9 here, then rear shows us the position of last element and front shows us the position of first element. First is already placed. I want to move last further. That's why rear should come here. Whenever we are putting an element inside queue, we have to increase rear by +1. Already rear is in 0th position. We have to increase it with 1. Now it is in 1 location. In this way, we have to move further. When we insert another element, for example, I am taking another element that is 10. Already front is placed in first location, rear is placed in second location. but I want to insert 3. Then I have to insert 3 in rear location. But before that, I have to increase rear first. Rear should be increased by 1. Rear is already in 1 location. 1 plus 1 is 2. Means in now rear should move further with second location, and the element should be placed, that is 10. 10 will be placed here. In this way it moves further. But what about if I am writing this, means rear will be in 4th location? What will happen if I want to insert 6th element? I had already inserted few elements. I want to insert 6th element. Then what will happen? Means we are not having any location for 6th element. Rear is already present in 4th location. We are not having 5th location to insert any element. Then what will happen? Now we have to show overflow condition. This thing we have to keep in mind during insert operation. Overflow condition we have to keep in mind. How? See, insert operation of Q is used to insert element. Yes. When we insert element, rear pointer increase by 1. I already told you. When we insert element, take care of overflow condition, means rear is equals to size. When we are dealing with algorithm, rear is equals to size. When we are dealing with arrays, then rear is equals to size minus 1. Then when we insert element in array, then we have to keep in mind that firstly increase the position of rear and then insert element in that position. And one more thing we have to keep in mind, that if first element is going to be placed in Q, then we have to place front from 0 to 1 in algorithm. And in arrays, in our programming, the front should be placed from -1 to 0th location, because rear already increased by 1 always. But what about front? We have to place front here. Then for putting it, you have to keep this condition in your mind, and you have to place this condition in your program also. When you are inserting an element, I'm going to show you how to create program, but afterwards. Firstly, I'm going to discuss about theoretical material. Now, moving further with the algorithm. Now I'm moving further with insert algorithm. See, Q U E is a Q with front and rear as pointer. Data item is to be inserted in Q and the capacity will be size. We can write in this way also. Algorithm insert Q is an array of n element. E is element to be inserted. Checking of overflow condition. How we are going to check? Rear is equals to size. Q is overflow. Or we can say rear is equals to n. Then display Q overflow and we will return it back. And if we want to insert element, then we have to check whether the front is equals to null or rear equals to null. Then we have to keep front in 0th location and we have to increase rear by 1. If we insert element, then we have to insert that element in rear position. And if we are writing in this way, then the else part will be, when it is not overflow condition, then the else part will be executed. And how it else part will be executed? If we are entering a first element, then front should then front is equals to 0, and we have to keep that front in first location, because rear always increase by 1, and we have to keep in mind that we have to bring front also in first location, so that front can be in first location always, and rear will increase by 1 for inserting element, and we are inserting e element in the rear position of q. In this way we will end our algorithm. Now see, what about delete operation? When we delete an element, the front will increase by 1. We have to keep in mind how. See, when the first person will already taken that ticket from the counter, then the second will come first, and the front position will increase by 1. The second will become a first person. When second person has taken that ticket, then the third person become the first person. Means front pointer should be increased by 1 always. This thing you have to keep in mind, 1 by 1. In one more thing you have to keep in mind, maybe sometime it happen that we are having only one element and we have to delete that element. Then at that position, front and rear both are in same location. When we are deleting this element, means nothing should be kept here, means now front and rear should come in -1 location for arrays. And for algorithm we can have 0th location or we can have null location in algorithms. Now see, in theoretical way, when we delete an element, front pointer increase by 1, I already told you, and we have to keep thing in our mind that underflow condition is there or not. And if underflow condition is there, means nothing is there to delete, then we have to display underflow condition. See, when we delete an element, then firstly, what if that q contains some element, then pick an element from q and increase front pointer by 1, any array we are having at that time. Now see, one thing you have to keep in mind, if element is only 1, then after picking an element, move front and rear to 0th location for an algorithm. And if you are talking about arrays, then keep front and rear in -1 location. Now delete algorithm. When we delete an algorithm, we want QUE is a queue with front and rear as pointers. Our data item is to be deleted from a particular queue, but queue should have a number of elements, that is size. The capacity of queue is size. In the same way, we can write algorithm delete q. Q is an array of n element and e hold a value of new element which is to be deleted. In check for underflow condition, we are going to check whether it is underflow condition or not before deleting an element. When we delete an element, we have to check whether front is equals to null, means q doesn't have any of the element, then front is null. Then we have to display q is underflow. And in another side we can write front equals to 0, then display a q underflow. Pick element to be deleted. Now we have to focus on the element should be deleted. We have to focus on it because q have some elements to be deleted. Now we have to pick that element from the front end and we have to keep it in position of item, a variable which contain a value of q which is present in q front location. We will pick the element and then we will display the element is deleted. Means if we are having an array of 4 element and front is present in the location number 0, In this way we are having our values. Front is in 0th position, rear is in 3rd position. If we are going to delete an element, then we are supposed to delete one first because it is the first element. Then when we have to pick an element and we have to delete that element, or what we have to do for deleting an element, we have to move towards the next element. Front pointer should be increased by 1. Always remember that when we delete an element, front pointer always increase by 1. We have to set that pointer. And one more thing we have to keep in mind, if we are having only one element with us, front is all pointing towards 1 and our rear is also pointing towards 1, means we are having same element, one element for rear and one element for front, means only one element is in Q and we are going to delete that element. Then what happened? Both front and rear should come in -1 location, because now Q is empty. That's why we have to set pointer. If front and rear both are equal, then we have to set them to null, because it is algorithm. When we are dealing with programming, we have to keep them in -1 location. Else front should be increased by 1, means we are having more than one element with us, then we have to increase front with 1. In the same way we can have our programs also. In the algorithm form I am writing concept of program also, so that you can apply directly these. In this way you can have your logic in your program. By applying this algorithm directly to your program, you can have your logic part. How? I am writing the same thing, picking an element from the front position and storing it in E, and I am returning that E. But before that I have to check whether we are having only one element with us. If we are having one element, then we have to specify that front should be 0 and rear should be 0 after deleting an element. When we are having only one element with us, then at that time when we delete an element, we have to keep front and 0. Front is equals to 0 and rear equals to 0. If we are having more than one element with us, then we have to delete an element from the front location, and then front should be increased by 1. That's why else part contain front is equals to front plus 1. In this way you have to write your program and then you have to end it. Now moving further with the display operation. Now you are having an array, full array to display. You can have few elements also, you can have full queue also. And when we have to display the elements, we have to keep in mind that the display operation is used to display elements from front pointer to rear pointer, means from starting till ending we have to display each and every element. And one more thing, if elements are not present in queue, then you have to display queue is empty. But now with us we are having so many elements, means complete queue we are having. We can display all the elements one by one. And when you are applying this concept to display elements, you have to keep in mind that you have to use loop, and loop will contain a variable which moves from front to rear, and then one by one you are going to display the elements of queue. I'm writing here ARR. Here I am writing ARR because in diagram I want to show any of the array you can have. So short form of array I am using, and in program I am using array name that is Q. Now see here I am using array name that is QUE. ARR indicates you it is a array. In this way you can display your elements from front to rear you have to display. And now see, in this way you have to display elements one by one. See, now we are having a question in front of us. In this way a question came in your paper. Always either stack or queue is always present in ISC paper, in both papers, in this format. See the question: a queue is an entity which can hold a maximum of 100 integers. Mean at most you can store 100 integers, not more than that. A queue enables the user to add integers from the rear and remove integers from the front. Means you have two pointers, one is rear and one is front. Front is going to remove that element and rear is going to add that element. You are having a class that is queue. The following details you are having: the class name should be queue, and the data members, or we can say instance variable, that is queue is an array which hold the integer elements. Size of array we are having, and front and rear both are the index who is pointing towards front and rear positions. The member functions we are having, that is queue. Int stores the size which is kept in size variable. Front should be -1 and rear should be -1 because we in present position we don't have any element. Then we have a void add yearly, means we are supposed to add element here. And if overflow condition occurs, then we have to display overflow. Int delete means element should be deleted from front end, and if we don't have any element, then we have to display underflow by returning -9999. And if we are having any element, then we have to return that element. After that we can display elements one by one. Specify a class queue giving the details only for functions. Assume that the other functions has been defined and the main function need not be created. Actually they don't want main function, but I am going to show you how the main function is going to be created. All the details I am going to show you one by one. Now see, we are having a program in front of us. Related with the question, we have to create our program. Match the question as well as the program. The question says class name should be Q. That's why the name is Q. And see the variables, what the data members we are having. See, QUE is an array which contain at most 100 integers. That's why I declared an array of 100 integers. Front and rear and size are the variables we have to use. That's why I written front, rear and size. Now after that, the member functions contain a constructor, a parameterized constructor which contains a size value which we have to store in size, and then front and rear locations will be -1. See, that's why I had written. But one thing keep in mind, that user can provide us size. That's why I declared a value of Q again. And now the value of Q is according to the user. The size of Q is according to the user. Now afterwards, see, we are having a function that is add ELE. Means we are having a value in V and we are going to add this element in rear position. See, if rear is size -1, we have to display overflow, because the question says us if already having a full queue, then display overflow condition. That's why we are displaying overflow condition. But I told you earlier also that if we are not having any of the element in queue and both the pointers were in -1 location, then we have to put f equals to 0 for first element, because the pointer should at least f should point towards the first location. Means if I am having value 5 and I'm storing it here, then I have to increase rear by adding +1. But what about f? F always point towards the first element. That's why I have to bring that f to 0. That's why I'd written this line, and then I'm storing value of that variable inside Q at rear location. Firstly, I'm increasing rear, and then I'm storing element in rear. Firstly, I'm increasing position of rear, means rear is in -1 location and I'm increasing it with 1, and then the position of rear is 0, means the first element, both front and rear, now pointed towards the first location, means 0th location. In this way we are going to have our addition element in Q. Then we have a function that is delete. In that we have to keep in mind the underflow condition, and we have to return -999. Otherwise we have to return an element which is to be deleted. Now see the functions we are having in front of us, that is delete. Front is equals to -1, means we are not having any of the element with us. It means we are having underflow condition and we have to return -999. If we have any element, then what? Then else part will be executed. And what we have to keep in mind, that we have to pick element from front position, and if we are having only one element with us, then we have to delete that element only. Then what we will do? See, in this way we are having only one element with us, means front and rear both were same. Then we had already keep 5 inside ELE. I had already kept it, and now the pointers were, is it possible to pointers to stay there only? No, we have to bring them in -1 location. Both the pointers should come in -1 location. That's why I written this. Front is equals to rear is equals to -1. Both should come in -1 location. That's why I written this line, because we don't have any of the element with us. Now if we are having element with us, means if I'm writing in this way, we are having elements with us and we are going to delete that elements. Then see, in this way I'm deleting that element. Then the second one will be the first one, because first one is deleted now. The second one will be first one. That's why f should be increased by 1. That's why I written front pointer is increased by 1, and I am taking that element back because we have to return that element. And after that we are having display function, which is going to display elements one by one. But if we don't have any element, then we will display empty queue, and if we have elements in queue, then we will display elements one by one, starting from front, ending on rear, and we will display elements one by one. And now see, next the question says we don't have to create main, but I had created for you so that you can able to understand how it is going to be worked. See, now you are having a function main. I had already created input stream reader buffer reader so that we can accept elements. The capacity of array is already stored in size, and I had created object of queue so that I can fill the size by calling a constructor. Automatically constructor is called Then the calling of constructor, fill the size of q, and after that, see, do loop I am using because one time I want to apply that menu, afterwards I want the choice of user. Firstly, I am allowing that user so that that user can see what is going on. First, if a user provide me 1, then I'm going to delete element. If user provide me 2, then I'm going to add that element. And if user going to provide me 3, I'm going to display that element. By accepting user choice, I'm having a case 1. In that, I'm going to delete element. And I told you earlier that delete function is going to return element. And then we have to store that element with us in ELE. ELE is going to be stored in E, and if it is minus 999, then I am not going to display any of the things. If it is not minus 999, then I am going to display the deleted element, because if minus 999 will return, before that we had already displayed underflow condition. Means we are not supposed to display it again. If we are having any element, for example 5, we have to display element deleted is 5. In this way we have our delete function. We had called that delete function and we had displayed that element. After that we are having a case 2. Case 2 is going to have element to add. That's why we have to ask from the user that which element you want to insert, enter element, and then we are going to have that element in ELE. And after that we have to call that function and we have to put ELE inside that function bracket, and then ELE should be stored in array particular location. After that, I created case 3 by calling display function. If user provides me other than these 3 values, then I am providing user that it is the wrong choice. And after that, I am going to ask whether you want to continue or not. If you want to continue, press yes. Means y or small y, anything. And see, in this way I had written, do you want to continue? If that person provide me capital Y or small y, I'm going to accept it and I check that whether it is capital Y or small y. I'm not using char because so many issues were coming with char. That's why I'm using string here. And if user provides yes, then I am going to continue the procedure again and again. Now see what happens when I am going to run this program. What will happen as output? See, I am showing you output, how it look like. Enter the capacity of array. I am taking 3. Then I am having menu with me. 1 is delete, 2 is add, and 3 is display. User provides me 2. Means that user want to add element in array, and array having capacity 3. Element is inserted means 88 is inserted here, and again asking that you want to continue, yes or no. If yes, then choice is 2. Again want to add element, means element is added here, means front, now front is here and rear is here. And again, do you want to continue? Yes. Choice is 2. Again element is inserted, that is 55. Now rear is here in second location. Now again asking that do you want to continue? Yes. If you want to continue, then you want to add any other element? Yes. That person want to add more element, that is 24. If that person want to insert 24 here, then we have to display overflow condition. That's why we are having overflow condition with us. Now see, If we are moving further, means we want to continue, yes, after displaying in elements, I want to check whether all these things happen. I told you earlier, all these things happen, and I want to see whether the elements what we are having. I told you that 88 is here, 100 is here, and 55 is here. I want to see these elements one by one. See, that's why the menu is in front of us. I have a choice, that is 3, and see the values we are having. 88, 100 and 55 one by one, means it is displayed in the same pattern from front to rear, means our logic is correct as our output. Now see, after displaying, I want to delete an element one by one. Then we are having our menu with us. Enter your choice, that is 1, means I want to delete element. The user want to delete an element, and the element is deleted, that is 88, because the first element is stored, that is 88. It is going to be deleted. Then the front should come in one location, rear is in second location. Then again the same thing, do you want to continue or not, and enter your choice. That is a third. See that I displayed that element. 155 is displayed, means working is going on the same way what we are having in the as concept of queue. The same thing. Do you want to continue? Yes. Again we are having menu. Again user want to delete element. Then the element is deleted, that is 100. Now it is deleted, means front come in the position of rear. Now value of front is 2. Both were standing in the same position. And see, again the menu appears. Do you want to continue? Yes. We are having our menu with us. What is your choice? There is 3, means now we are having only one element with us, that is 55. Now what? If you are able to understand it well and good, if you don't, do ask from me. Otherwise, goodbye and good luck.